volume, and the first one's going to be cross sections. Okay, I'm going to tell you two things. Number one, this is not hard, but number two, it's kind of hard to think about what it would look like.
Can I just say that that's what you said last week?
And it wasn't hard.
Very confused.
Oh, okay. Well, that might not be good then. I don't know. Okay, so when you want volume, you know hopefully from last week how to find area. Volume is the integral of area. Okay? So if you have an area equation and you really wish it was volume, you just have to integrate it from A to B, where A to B is going to be your domain because we're only doing dx today. Okay? Now when I say domain, usually those are like the places where the graphs intersect. We're going to do all of that still. That'll be the same. Okay? So, little bit of geometry review for you. Okay, ready? You're going to be a geometry superstar. How do you find the area of a rectangle?
Length times width.
Let's do base times height, but yes. Okay, how do you find the area of a semicircle?
Pi r squared divided by 2.
So I'm going to do 1/2 pi r squared, but that's the same as what you just said. Okay, we're going to skip semi-ellipse for a second and go to square and triangle. How do you find the area of a square? Good. Okay, remember that if your base and the height are the same, then you can just put b squared, yeah? Okay, and then for a triangle, it would be 1/2
Base times height.
base times height. Very good. Okay, the only one that we skipped is the semi-ellipse, and it's because, sadly, some of your pre-cal teachers don't always cover ellipses. Did they cover ellipses?
No.
Yeah.
I think so, yeah.
Some? Okay. That's okay. So draw an ellipse. An ellipse is like an oval.
Yeah, Mr. Burley's in that.
No? That's okay. You probably know an elliptical. The wheels move in an ellipse, okay? Just ruined your workouts for the rest of your life. Okay, it's an ellipse. So with an ellipse, here's the difference. Okay, when you have a circle, all of the points on the circle are the same distance from the center, yeah? So you only have one radius. There's no point in dividing it into two separate radius measurements. For an ellipse, you have two different radius measurements. One of them runs up and down. The other one runs across. Now, usually the letters that are used for this are A and B. But to avoid it being confusing, we're going to use J and K instead. Hi. Thank you. It's for you, Kevin. But it says when convenient. You're counselor. Yep. I disagree with that. Okay, so here's how you find the area of an ellipse. Okay, are you ready? Area equals pi j k, where j is one of the radius distances, k is the other radius distance. Now what if I only wanted the area of half of it? What would I put in the front? 1/2 pi j k. Okay, versus on a circle, your j and your k would be the same. That's why they just call it radius squared. Okay, there's no sense in having two separate measurements on a circle because they're the same. Got it?
Got it.
Okay. The other thing you need to remember is your special right triangles. Okay, let's see whose geometry teachers made you remember this for life. Okay, 45, 45, 90. If two angles match,
They're x's.
okay, the sides have to match, so we're going to label each of those with a B instead.
And then the other angle is b root 2.
B root 2. Now, some teachers will put root 2b, it doesn't matter, but don't put the b under the root. It has to be separate, okay? Now, these would both be your 45s. Whenever two angles match, two sides have to also match. That's like a geometry rule. Okay, other one, 30, 60, 90. There's only two. It's going to be the same two that you're going to see over and over again. This is going to be your 60. This is your 30. And then your short side, we're going to call B. Okay? What is the relationship, who remembers, between the short side and the hypotenuse? Double. 2b. Good. Double is right. The other one has a square root in it. Root 3. And then you can put the b in the front or the back. I don't care. I'm going to put it in the front, but it's the same thing. Okay? So if this is the base, let's say the base was 5, then this would be 5 root 3. That would be 10, because it'd be double. And that relationship between a 30, 60, 90 triangle is always true. What if this was 10? What would that be?
5.
Half would be 5. That would still be 5 root 3. So those relationships are always the same. Got it? Okay, so we're going to do some steps, okay, and then we're going to do an example. So look at the first one. You're going to set up the region of the base. Okay, oftentimes this is going to include finding intersections. And how do you find intersections? Set the equations what? Just like last week. That part should be the same. Okay, then you are going to integrate dx if your cross sections are perpendicular to the x-axis. That will be important later, but today we're only doing dx's. So no matter what, you're integrating dx today. You don't have to worry about picking. Okay, you're going to write the formula for the base. It's always going to be the top minus the bottom. That should also look familiar. That's how you find the area of a sandwich, right? You do top minus bottom. Okay, and then you are going to write your base formula as an expression of x. We'll talk about that in a second. Okay, number 3, you're going to write your area function. And then your integral is going to be the integral of a of x dx from a to b, where that chunk right there is your area formula. Okay? Now, I'm going to show you a little thing on the computer, but I'm going to try to draw it first so you know what we're doing. This is the part that I would say don't overthink it. Just watch. The actual process is not very hard. It's just weird looking. Okay, so here's what's going to happen. You're going to have a region. Okay, so draw. Let's go here and then here. Okay, that's your region. That region that you just drew is going to be the base of a solid. Okay, so pretend like that is on the ground, and then you're going to construct a solid out of that base using one of the shapes that we just wrote. Okay, so there are a bunch of different types. Okay, let's pretend, just to make it easy to draw, that you're going to do, let's say, a rectangle. Okay, so ready? I want you to draw a line here to here. And then I want you to draw a rectangle and pretend like it's coming out of the paper. Okay, and then you'd have another one here. And then another one here.
Are those rectangles?
They're supposed to be like standing up, you know?
Oh, okay.
Yeah? And then from there, you have kind of like this little slug shape coming out of your paper. Okay?
I don't know how to draw that.
Okay, welcome to technology. It's okay. So now I'm going to make it better, and I'm going to put it on a screen. Okay? If you can't visualize that, I tried. It's okay. Oh, it won't let me switch. Okay, I have to put my computer up here. Hopefully we don't lose Nora. I don't know. Okay. Oh, wow, look at that! Wow! Now we are freaking people out. Okay.
Oh my God.
Okay, this is what I meant to give you. Okay, so look, right now I have it on. Let me go back. Okay, you're just watching right now. Okay, do you see that you have like a region graphed here? So this is the x-axis, this is the y-axis, it's the shape of a triangle, okay? What I'm going to do now is I'm going to construct a solid with semicircles. Just watch. James, don't make that mean-looking face at me or I'm going to cry. Okay, look, watch. Here it goes. Whoa. Okay, you see it? Okay, now I'm going to make it go away, and now I'm going to pick a different shape.
Wait, but do we really have to draw this?
You don't ever have to draw. That's what I'm saying. I'm showing you because some of you are probably curious. Most of you probably don't care. That's okay. Okay? Look at the next one. Hold on, not that one. Okay. Let's do, okay. Okay, do you see I have a rectangle? Now look what's going to happen. I'm going to construct a solid using that shape. Okay, and now do you, oh, I lost it.
I just see a cone.
That ain't no cone, girl. That's a triangular prism. Okay, but it depends what shape I pick. Okay, now I'm going to pick a different one. Okay, let's go back. Okay, let's say I want to pick a semi-ellipse. And I want it to be a height of 3.
Can you change the base shape?
I can't. And that's where, like, if I have, like, a really fancy thing, I could change the base shape. And your base will be different. It won't always be these graphs. Okay, so now look, watch. Ooh, I forgot it's touchscreen. Look what happens. Ooh. See? And you can make these little shapes. Now, think about, no matter where I slice it, what shape am I going to see? A semi-ellipse. Okay, now look, watch. I'm going to pick something else. Let's say I do a triangle. Boom. No matter where I slice it, what shape would I see? Now, are some triangles taller than others? Okay, but are they all the same shape? Yes. Okay, now, if that confused you, just pretend it never happened, and I'm going to show you how to do it. But that's what we're finding the volume of. Okay? Did that help you to visualize it, or probably not? Okay.
It shows a really weird base shape on the paper.
Yeah.
I think that's what it was.
Yeah, that's probably true. That's okay, though. Oh, you mean like on the paper you wanted me to pick a different shape? When you, yeah, you're probably
It's all
right.
good.
You're probably right. Okay, so turn over. We're going to do it. Ready? Let's do x squared minus 1. What does that look like? Okay, so we have to do 2. So x plus 1 would go through positive 1, and it goes uphill, yeah? Everybody good to there? Okay, equation number 2 is x squared minus 1. So that's going to be quadratic. It's shifted down. So it would be like that. Okay, do you see your base region? Okay, it's right here. Okay, what did we write next to step number 1 after you sketch your region? What are you going to have to find?
Your
Intersections. Good, and how do we do that?
Equal them together.
Equal them together. So I'm going to let x plus 1 equal x squared minus 1. Okay, so what I'm doing right now, if you'd like to label it, is you're finding the intersection. Find intersections. Okay, so I'm going to minus the x across to the other side. So now it's a minus x. And then do my 1 and negative 1's cross out? No. What would I get on the right side now? Good. When I cross that plus 1 out, I'm minusing 1 more, so now it's a minus 2. Can that be factored? Okay, how would it factor? I want negative 2 and negative 1. Minus 2 plus 1. Which means that what are my intersection points? Good. So this one has to be my positive 2. This one has to be my negative 1. Okay, everybody good to there? The next thing that you're going to do is pretend like it's like, I don't know, a weird shaped loaf of bread, and you're going to slice it. Okay, I'm going to highlight the part of the sentence that tells you which way to slice. It says your cross sections, that's your slice, is going to be taken perpendicular to the x-axis. So what I'm going to do is pretend like your little pen is your knife, okay, and you're going to slice it like that. Now, which way is that running? Perpendicular to what? The x-axis. That's what it says, so that's what we did. When you write the formula for your base, that's your base, it's going to be top minus bottom. And this is exactly like what we did last week. Which of those equations forms the top border of our region? X plus 1 minus, what's the bottom of the region? X squared minus 1, good. Now, I could leave it like that, but it would be better for you to make it simpler. So I'm going to have base equals x plus 1, and actually what can I do with the plus 1 and the minus negative 1? combine them. But if it's minus negative, that's really a plus. It'll be a 2. So I'll have x in the front plus 2, and then my minus would still be on my x squared. Yes. Well, okay, if you don't, you'll have a lot more to write down here. So that's why we're doing it. Okay, so up until there, what did we do? We graphed our region, found our intersections, and then we wrote that our base is the top minus the bottom, and we made it simple. So far, so good? Okay, what happens from here is the AP test is going to pick one of the shapes that we already wrote the formulas from on the front. They're never going to pick all of them. Why am I having you pick all of them? Because I don't know what they're going to pick, right? So the first one is a square. This is the easiest one. How do you find the area of a square?
Base squared.
Base squared. And how do I get from area to volume? Volume is the integral of area. But what is my base if I want to square it? We just wrote it right here. What's my base? X plus 2 minus x squared. And then where am I going to integrate from? Take a guess. Think about what you know from last week. Negative 1 to 2, because that's where my intersections are. And you're done. And then put, yeah, now you're done.
You don't have to solve for it?
Now, sometimes you will, sometimes you won't. But a lot of times, these end up being complicated enough that you would either have a calculator or it would say set up but do not evaluate, and you would just only be writing the integral. Okay, now obviously the square is the easiest one, so let's move over one. We're going to change the height here to be a 5. Okay, so how do you find the area of a rectangle?
Base times height.
Okay, area equals base times height. But what height did they give me for these rectangles?
5.
So my area is going to be whatever the base is times 5. So I'm going to put 5b. That's the area equation. How do I get from area to volume? I do the integral. So volume equals the integral of 5b. And then what's my b?
X plus 2 minus x squared.
Minus x squared dx. Where am I integrating from? What's my domain of my region? Negative 1 to 2. Okay? Let's go down to the next one. Oh yeah, I changed it to a 5, so because a 1 we wouldn't even have to write, right, if you times by 1. Okay, look at letter C. I want an isosceles right triangle. Okay, draw for me an isosceles right oh, these should be the same. Pretend those are the same, okay, even though they're not really. How do you find the area of just any triangle? Doesn't matter what kind. 1/2 base times height. If this is isosceles, you have two eyes, isosceles, so two sides match. So if this is the base, what could I call the height? If they're the same.
Base.
The base again. So how could I make this formula a little bit easier to take the h out? 1/2 base squared. But remember, why can I call it base squared? Because if it's isosceles, those two sides match. Okay, then how do I get from area to volume? I put an integral on it. So volume equals integral 1/2 b squared dx. And then when I get to my b, I'm going to substitute that top minus bottom formula that we had written earlier, which was x plus 2 minus x squared. Now, what are my boundaries going to be still of my region?
Negative 1 to 2.
Backwards, yeah, negative 1 to 2. Make sense? Okay, we're going to equilateral triangles. Okay, the good news for you is, remember, how many specials are there? Only 2. 45, 45, 90, 30, 60, 90. So if it's a triangle, it's going to be the same triangles over and over again. Okay, but I know this is the first time you're looking at it. Draw an equilateral triangle. All three of your sides should be the same. You're going to have to use our imagination on mine that they're the same. Okay, pop quiz. If all three sides are the same, what do you know about all three angles? They have to be the same. So if all the angles add up to 180, and I divide it into 3 equal angles, how big is each angle? 60. So this one's 60, That one's 60. That one's 60. That's called equiangular, okay, in case you care about that. Now, if I want to find the area of that triangle, I need 1/2 base times height, yeah? Can I use this side as the height? Why not? It's not the height. The height has to be measured how? Straight up and down in the middle. It can't be like a skewed sideways side. So this is my height, yeah? So how many triangles, if I draw my height, then do I have? Not just one, but 2. Okay, now remember, how big were all the sides of all the angles? Okay, so this one is still 60. How big is the top one now? Ooh, look at it now. What is it? A 30, 60, 90, right? Okay, so when you cut your equilateral triangle in half, remember this dotted line here is the height. So if I want to know how tall the triangle is, I'm going to have to use special right triangles. Now, the entire bottom is the base. How long is the short side? Half of the base. And then remember, what do I multiply by for my other leg of my rectangle? Is it the 2 or the √3 side?
2.
√3.
Can you repeat the question?
Okay, yeah, I'll repeat it. So if this is the short side, the longest side is double. What do I multiply this side by? √3. So I'm going to put right here an arrow. My height is going to be half of my base times √3. Now think about that for a second. It's half of a 60, 60, 60. That makes it a 30, 60, 90. That makes this my other leg. So whatever this is, if I multiply it by √3, that's how long the missing side is. That missing side is my height. Okay? So I'm going to come to here. I'm going to leave my base alone. That's not the problem. I know what B is, but I'm going to substitute for my height. What am I going to substitute?
1/2 base √3.
Good. So my area formula is going to be 1/2 base, 1/2 base √3. So the only thing that changed is I took my h out because I don't have a substitute for that. And I'm putting in my ratio from my triangle. Now, at this point, you could integrate that, but it looks kind of funky, right? So instead, we're going to just simplify it. What's half times half? A fourth. And then if I multiply my fourth times my √3, it would be √3 over 4. Is everybody good with that? So half times half is a fourth, and then I put my √3 on top. Now, how many b's do I have? 2. So it would be squared. And then if that's my area formula, how do I get from area to volume? Integrate. Very good. So volume equals 3 over 4 integral -1 to 2 of my base squared dx, where my base top minus bottom was that. Okay, and then that would be your answer. If it's on the calculator part, you could use your calculator to integrate it, but a lot of times they don't even make you do that. Okay? Alright, we have 2 more shapes left. Next one is the semicircle. Okay, so draw a semicircle for me. And remember that all of this is the base. How do I find the area of a semicircle? We already wrote it on the front. Okay, now notice I want that R to be a B. I don't want to know about R. I don't have a substitute for R. So think about, how does the radius of that semicircle compare to the base? It's going to be half of it, right? So if I draw my radius in here, my radius would be half of the base. And then remember, just like last time, I'm going to take that half B and I'm going to plug it in where my R is. Because R doesn't do anything. I don't know what the R is in terms of X, but I know what B is. And remember, we're going to make that equation simpler before we put the integral on it. So my area would be 1/2 pi. And then instead of R, it's going to be a half B squared. Where my R is now half of the base. Any questions to there? Okay? what is my b going to end up, what power is going to be on it? B squared. Okay, now let's do the number part, so stay with me. What is a half if I square it? A fourth times by another half, 1/8. And then where could I put my pi? On the top. So one more time, if you're confused where that came from, okay, let me try one more time to help you get it. Okay, I did 1/2 b in place of my radius. I squared the 1/2 and got a fourth. Then I times by the extra half and I got an eighth. And then I just put the pi on top of the eighth so that they're not separate. An eighth of pi is the same as pi eighths. And then how do I get from area to volume? Integrate. So my volume would be the integral from -1 to 2 of pi over 8, and then my base squared, where my base would be x plus 2 minus x squared again. Okay? Okay, the last shape, and then the next example is going to be way easier because you'll have already seen all of them. Okay? Let's go to letter F. So we want semi-ellipses of a height of 2. So draw an ellipse. How many radius measurements does an ellipse have? 2. You have one here. That's my J. And then, oh, you can't even see that. Okay, you have one here. That's my J. And then you're going to have one here. That's your K. Okay, read what it says. What is the height of my ellipse always? Okay, it says I want a semi-ellipse with a height of 2. So, what is K always? 2. Now, J, remember, this entire distance is the base. So, what would I call J? Yes, half of the base, right? Because this is only half of the way across. Because it's a radius, it's not a diameter, it's half of the way across. Yeah? So then when I set up my area, remember it's 1/2 pi jk. And then my j is what?
1/2
Half of the base. What's my k? So it'd be 1/2 pi 1/2 b times 2. And then what will happen there to make that one a little bit easier?
So it'd be 1/4 times 2.
Yeah, and before I do that, what's half of 2? They just cross out. Or you could just put a 1/2 in the front, either way. Okay, but the half and the 2 just cross out with each other. So what would my final area function be before I integrate it?
Pi over 2 times b.
Yep. And you could write it the way that Valerie said, 1/2 pi b, that's fine. Or you could put the way Sumaya said, pi over 2b. It doesn't matter. They're the same, it's just how you write. And then how do I get from area to volume? Integrate. And then my base was good. Make sense? Okay, you've seen all of the 6 shapes that they might use. So we're going to do another example, and it's going to be several shapes, and then we can work on your homework some if we have time. Well, we probably won't have time, but maybe. Easy? Okay. Actually, let's do one off your homework. Set up number 1 for me. Just the first one. Just set up the region first. So it's y equals what for number 1? X squared. Everybody knows what that looks like. And then what's the second equation? Y equals 9.
Are you graphing it?
Yup. Okay. Then what do we do from there?
Make it equal to each other.
Set them equal to find what? To find the intersection. So set those equal to each other. You can probably do it in your head. Okay, where are they going to be equal?
Plus minus 3.
Good, you'd square root, x equals plus or minus 3. So this side over here is x equals -3. This side over here is x equals 3. So far so good? Shade your region. between those functions. That would be here. Still good? Okay, part B. Set up but do not evaluate an integral for the area. How do we find area with an integral?
Find the base first.
Okay, that's for volume. So go back to last week. What would my integral be for area? Where to where?
Top minus
From negative 3 to 3, top minus 1.
Negative 3 to 3. What's my top function?
The
y
line.
equals
9. What's my bottom function?
is x squared.
X squared. Yep. Dx. Okay, so notice all they wanted was area. Then you just integrate top minus bottom. Okay, now look at the next part. Set up but do not evaluate an integral expression for volume. That's what we learned today. So, several steps. First step, draw in your base. Your base should be perpendicular to the x-axis. That means that when you slice it, you're going to slice it like this. And which way does that run? Top minus bottom, right? Who's on top? 9. Who's on bottom? And no matter what shape they pick, that's your base. Every time. Your base is 9 minus x squared. Okay, now let's see what shape they picked for letter C. Says I want to have a rectangle with a height of 3. How do you find the area of a rectangle?
Base times height.
Okay, base times height, but what's my height? 3. So my area is going to be base times 3. Now, does the order there matter? No, I'm going to put or 3b. Okay, but it's the same thing, and it doesn't matter. Then how do I get from area to volume?
Integrated.
Okay, volume equals the integral from where to where? Negative 3 to 3. And then I would take 3b, but what is my b the same as?
9 minus x.
Good, 9 minus x squared that we found earlier. Dx. Okay, go down to the next one. They're going to change up the shape on you, but your base is going to be the same. 9 minus x squared. Okay, read through it, find your shape. Should be one of the ones that we looked at. What's the shape? Semi-ellipse. So let's set up a semi-ellipse here. Remember, how many radius distances do you have on a semi-ellipse? 1 horizontal, 1 vertical. And remember, the horizontal one is going to be b over 2, or half b. It doesn't matter, whichever way you want to think about it. What does it tell you about the height?
It's double size of base.
Double the base. So what would I put for my other side here?
2b.
It's double the base. So one of them is b over 2, the other one is 2b. How do I find the area of an ellipse? It'd be pi jk, cut it in half. But then now I know what my j and my k are. My j is b over 2, my k is 2b. So it'd be 1/2 pi, 1/2 b, 2b. What's going to happen with the 1/2 and the 2? Cancel out. What is the power on my b now? B squared, and I'd have a pi over 2 in the front. And then from there, that's area. How do I get from area to volume? Do the integral. So volume equals negative 3 to 3, pi over 2, and then my b is 9 minus x squared, squared dx. So the middle part here should be your base, and then you're plugging it into your area formula. Does that make sense?
Why is it squared?
Because 9 minus x squared is the base, and the squared comes from the fact that it was this b times that b. Okay? Okay, let's do that last example off your homework, and we may not have time to do every single shape, but we can maybe do 1 or 2. Okay, skip this x squared plus y squared and just go to the last one. Okay, both of my shapes are quadratic. What does negative 2x squared plus 9 look like?
The facing down, narrow quadrant.
Down, narrow, okay? So this is just the last page of your notes. Okay, next one. What does it look like?
It is a normal quadratic, but to the
Shifted,
right.
oop, down 3. Remember, it would have to be in the parentheses for it to shift it to the side. So one of them opens down, the other one opens up. Here's my region. What will we do next? Think about what we just did on your homework. Find where they what? Okay, find the intersections. Okay, which you should be able to hopefully do. Find intersections. So I would let negative 2x squared plus 9 equal x squared minus 3. Okay, I'm going to move my minus 2x squareds over here. How many do I have now on this side? 3x squared, yeah? Because you're adding the minus 2 across, so it'd be 1x squared plus 2x squared makes 3x squared. Okay, then with my 9, I have a 9 here, so I'm going to have to minus 9 from negative 3. What will I get? Good. What can I factor out of that? 3. And that would give me x squared minus 4. So hopefully we can solve from there. Where are my intersections? Negative 2, positive 2. Next thing, draw in your base for me. Your base should run perpendicular to the x-axis, which is the only way we're doing it today anyway, but that means it runs this way. That's my base, right there. So I'm going to do top minus bottom. Which function is on top? F or G?
G.
F. So negative 2x squared plus 9 minus, who's on bottom? X squared minus 3, which is G. Now, you can leave it all complicated like that if you want to, but we're going to have to rewrite it several times, so we're going to simplify. What is negative 2x squared if I minus 1 more x squared? Negative 3x squared. And then what is 9 if I minus negative 3 more? And then that's going to be my base, and I'm going to reuse that no matter what the shape is that they pick. That's the distance across the base of your region. Okay? So set up the square one for me. That's the easiest one. Okay, we want it to be a square. What would your area formula be? B squared. Then how do you get from area to volume? Integrate. What will the boundaries of my integral be? Negative 2 to 2. And then what's my base? Negative 3x squared plus 12 squared dx. Remember, this in here is your base, where you do top minus bottom. Okay? Next one, I want a rectangle, but I want the height to be 2x plus 1. No problem. How do I find the area of a rectangle? Base times height. But what am I going to use for height? 2x plus 1. So it'll be area equals the base times 2x plus 1. And then how do I go from area to volume? I make it an integral. Negative 2 to 2. What is my base substitute here? And then what's my height substitute? 2x plus 1 dx. And then if you were asked to do that, that would either have to be in the calculator or you would have to times all that crap in and it would take forever, but you could do it, right? Okay, next one, I want a semicircle. Okay, let's do a let's do a semicircle. Okay, here's your thing. What is the radius of the semicircle from here to here? Half of the base, 1/2 b. And how do I find the area of a semicircle? Pi r squared, and what's my r going to be? 1/2 b. You should be having deja vu. We already did this, right? Okay, what is 1/2 if I square it? Multiply by the extra 1/2. What would that be? 1/8. So I'm going to make it a pi eighths b squared. That's the same. A semicircle will always be that. Pi eighths b squared. If you want to memorize it, you can, or you can just refigure it out. Okay, integrating where to where? Negative 2 to 2. Those are the boundaries of my region. Then I want pi eighths b squared. And my b would be the equation that I found at the beginning, that it doesn't make a difference what shape it is. You would always use that same top minus bottom. Now, why would we want to write it like this versus leaving it like that? This is why. If you had to do this integral by hand, could you move the pi eighths to the front? Yeah, and that would make it a lot easier versus having to work with it in that form. Okay? Semi-ellipse whose height is 3. Draw your semi-ellipse. What is this part going to be for J? Half of the base. What does it say the height is going to be? K is 3. And then remember, how do I find the area of a semi-ellipse? 1/2 pi jk. What's my j? Half b. What's my k? 3. So it would be 1/2 pi 1/2 base times 3. What would my constant in the front be if I combine this, this, and this? Just think about it for a second. Okay, half times half is the easy part. What's that? A fourth. Times by 3. Now it's a 3/4. And then remember, you can always just put pi with the fraction so you don't have to deal with it. And then my b is kind of alone on that one. And then remember, that's area. How do I get from area to volume? You put an integral on it. Now, could I put the 3 pi-4ths in the front if I want to? Yeah, because it doesn't matter, right? As long as it's there, it's a constant. And then my b, you would just be my thing I had earlier. Negative 3x squared plus 12 dx. Okay, last one. I'm not going to make you rediscover it, but remember on your equilateral, if this is b over 2, what's the height? You remember? B over 2 root 3. You remember doing that? And then let's peek back. Was it 3/4 or something? Right here. Remember our formula? It was root 3 over 4b squared. And then if that's area, how do I get from area to volume? Put an integral in the front, and then you'd be done. Okay? Now, if you go through and memorize all of those formulas, you're welcome to do that. I think it's kind of a waste of time, but that's because I don't think it's that hard to find them. So if you prefer to memorize, you totally can. But you can only really memorize for equilateral triangles and circles. The other ones, they could change the height or whatever to make it where you couldn't memorize it. Okay? Okay. We'll do this dy tomorrow.
That's gonna be exhausting.
Exhausting or fun? Which one?